All right, for our first lesson of chapters 8 and 10, we're combining those into one unit here. So this will be the first lesson within that unit. In the first section, we're just talking about relations and functions. And so a couple things we're going to identify throughout this. A relation, typically we see it as an ordered pair, an x and a y. So a relation is anytime you relate two items together, like an x value and a y value. Domain and range, we're going to get more into that here in a second. So let me just start going through with a few examples. So as far as identifying domain and range from or a group of ordered pairs, domain we always think of as representing the x coordinates, and the range comes from the y coordinates. So when I list my domain, I simply list the x coordinates. If you ever have any that repeat, then don't list it twice. So you don't need to repeat your values. But for the x's, I see a 0, a 1, a 2, and a 3. So that'll be my domain. And as far as the range, we just list the y values. So 0, -3, +2, and 5 are going to be the range. So 0, -3, +2, and 5. And that's domain and range. Given a rule like this, so we have the function y equals x plus 2, where x is an element of 0, 1, and 2. So this is just a way of saying I have a set of numbers, 0, 1, and 2, and x can only come from that set of values. So if I was to express the results as ordered pairs, simply means my x's are 0, 1, and 2. And so that's going to make up our x values for this. So 0, 1, and 2. And as far as getting the y values to go with them, we're just going to plug those into the function in order to get the y values. So if I plugged in a 0, well, we know 0 plus 2 is 2. If I plugged in a 1, the result would be 3. And if I plugged in a 2, the result would be 4. And so that's how it would look as ordered pairs. A mapping diagram lists the x's and the y's, but it lists them vertically. So I would have my x list like this, and my y values 2, 3, and 4 over here. When you create the mapping diagram, all they do for that is they draw an arrow for which x goes to which y value. So since 0 goes with 2, I would draw an arrow from 0 to 2. Since 1 went with 3, I'm going from 1 to 3, and 2 went with 4. So the arrows show basically what the ordered pairs were. It shows which x value goes with which y value, and that's our mapping diagram. So I think they oftentimes will have kind of an oval surrounding the x's like this, and around the y's like this. But that is our mapping diagram. If you're asked to determine the domain and range from a mapping diagram, real simple. The domain are the x's and the range would be the y values. So pretty easy to see from those. So for example 3, just given another scenario. So this just says that I'm simply going to use all the x's that are greater than or equal to 0. So it says or equal to 0. So I would just start with 0 as the first x that I'm going to plug in. And it says greater than or equal to 0, so then I'll use a couple numbers that are greater than 0 as well. And we'll just see what that gives us so far. But if I start plugging in those numbers into this function, if I plug in a 0, well, 2 plus 0 is 0. It's the same function that we had up above here. It's written in a different order, but it's still the same function. The difference on this one, so we're going to get the same results over here. So the difference on this one, though, is this would keep on going. That keeps on going forever because this one simply said it's greater than or equal to 0, where this one was limited to only 3 values. But this one it goes on forever towards infinity. So as far as writing our domain and range for that, well, the domain was given to us. That was x is greater than or equal to 0. So what would the range be? So if you look at the range values, notice these start from 2 and are going to go up forever. So the range values are y values that are greater than or equal to 2. So and I'm just basing it off of the results that I'm getting as I go down that line right there. So moving on to example 4. Again, this one right here says x values that are between -1 and 2, and they're giving us another function. So let's just start with -1 here and see what that gives us, and we'll plug in a few numbers into this. So 0, 1, and 2. So those are all the numbers from -1 to 2, including -1 and 2. But if we start plugging those in, 4 minus -1 is going to give us 5. 4 minus 0, 4 minus 1, and 4 minus 2. And so those are the numbers we put in. These are the numbers we get out of that. So as far as determining domain and range, again, this one, again, they give you the domain. That's the setup that we see right here with the x's. So that's our domain. So what do we list as the range? Just something you got to be a little careful on, because automatically students want to assume that these 4 numbers are the range. The only problem with that is, what about the numbers in between them? So what about 4.5 or 3.2? This didn't say anything about this being limited to only integers. We have to make the assumption that my domain is anything between -1 and 2, including decimals, fractions, every rational number you can come up with. So we can't just write the range as these exact numbers. We have to write it as another inequality set like we have here. So as far as the y values go for the range, we can see that it's between 2 and 5. And so we can at least say that it's all the y values that are greater than or equal to 2 or less than or equal to 5. And that then implies that it can be any rational number between 2 and 5. And so that's going to be our range. Moving down here to number 5. All right, so a little different on these only because they're not giving us a domain to start with. We have to figure out domain and range for example 5. So looking right here, as far as identifying the domain, remember the domain are your x's. And so we're looking at that equation and we're saying which x's, if I wanted to start stubbing in numbers for x, what numbers am I allowed to sub in for x? Or is there anything that x cannot be? Whenever you're trying to make this decision, there's only 2 limitations that you ever run into, and I'm covering both of those with these 2 examples. So anytime you're dealing with square roots, the limitation is that, well, you can't take the square root of a negative number. So whatever's under that radical, in this case it's x minus 3, has to be 0 or bigger, otherwise I'm going to end up with a negative under that radical, which we can't have. So as I add that 3 over to the other side, that inequality tells me my domain. It tells me x's can be 3 or bigger, and those are the numbers that I would be allowed to plug in for x. So this is our domain inequality right there. And as far as the range goes, a lot of times these are easier to see on a graph, but even for this, I can determine it by looking at the function as well. So if I started plugging in x's that were 3 or more, just like we did in the last problem, that's going to start giving me some range values to go with it. But as I start plugging in a value like 3, well, 3 minus 3 is 0, the square root of 0 is 0. And as my numbers keep getting bigger, my y values would keep getting bigger. And so as far as the range goes, it's going to be all the y values that are greater than or equal to 0. And just real quick, there's a way we could do that on the calculator as well. We plugged in the function that we're working on right now, the square root of x minus 3, and as I go to graph that, so take a look at what happens. So again, remember the domain is always what's going on with the x's from left and right. Well, if I look at the x-axis, I can see that it starts at 3 and goes to the right forever. So that's where we get our domain, that it's x's that are greater than or equal to 3, because that's what our graph is doing from left to right. The range is what your graph is doing from bottom to top. So you'll notice on this that the lowest value on that graph right here is where y is 0, and then from there it's going to continue in the upward direction, and so it's y values that are 0 and higher. And so that also helps us identify the range, is when we use the calculator like this. Looking at the next part of this, again, I told you there were only 2 limitations when it comes to domain from a function like this. One is with square roots, and that's the way we dealt with the square root limitation. The other is with a fraction or a rational expression. Anytime you have an x in your denominator, that creates a limitation because you can never divide by 0. And so the one thing that this graph cannot represent is a denominator that equals 0. As I solve this little equation right here and get x by itself, subtract the 2 and then divide both sides by -1. So as I solve that equation, this is the result that we come out with, and so it tells me that x can basically be any number except 2. And so when you say something like x is not equal to 2, that implies that it's every other number except 2. And so this is a common way of writing that for the domain. As far as is there any limitation on the y values of the results for this, because the denominator could never equal 0, there's no number I could ever sub in for x that's going to get 0 out of this, because the only thing that I can divide by are numbers that are not 0. So 3 divided by anything is going to be any number except 0 for this. So as far as the range goes, its y values could never be 0 for this guy. And let me show you real quick on the calculator how we could have done that as well. So I'm going to graph the 3 over 2 minus x. And you do got to put the denominator in parentheses, otherwise you're going to get something different on this, so don't forget about that. But as you look at this graph, you'll see where what we call the asymptotes, or the boundary lines, are for this graph. So I got my vertical boundary line right here at +2. Right, so there's a line, an imaginary line running right here that my graphs don't want to cross. And that's simply because x could never be 2. So my graphs come all the way up next to 2, but they don't actually land on 2 because x can't be 2. And so that's one way of identifying the domain. Same thing for the range. As I'm looking this way, you'll notice that my graphs never want to hit where y equals 0. So they come real close to it, but they're not actually going to land on 0. And so that's why we'd say by the graph that y's cannot equal 0. All right, last one down here to finish this off. All right, so taking a look at this, one thing that helps as far as domain and range, if you're just trying to look at the function, it helps if you understand what kind of a function this would look like. So we know that a squared function represents a parabola, and so I know I get a U shape out of this. So as far as this one goes, if we were to graph these guys, there's really no limitation on the x's because I don't have a square root and I don't have an x in a denominator. Remember, these are your only two limitations. So if I don't have that going on, that means x could be any number I want it to be. There's no limit there. So as far as the domain goes, we would just simply say something like all real numbers for the domain. But as far as the range goes, keep in mind that as I plug in any number right here, I'm going to square those and then add 1. And so the range, and this is best if I show you from the graph. So if you take a look at this function, so remember we're going to have a vertex on this parabola right here at 3, 1, and that's going to help me determine my range. So as you take a look right here, again the domain is whatever your graph is doing from left to right, and this graph is going to go left forever and it's going to continue to go right forever. So that's why my domain is all real numbers. But as far as the range goes, remember the range is up and down. So for this graph right here, the lowest range value is 1, and then from there it goes up. So for this graph, we're talking about all the y values that are greater than or equal to 1. So never be afraid to use the graphing calculator to help you determine domain and range. It really is a pretty helpful tool for those. Alright, so I'm going to give a couple homework hints here as far as helping you with being able to determine domain and range from the graph itself. So if I didn't have anything else to look at but the graph, like you're going to see these are some of your homework problems, how would we do that? And so keep in mind that your domain, you're always looking left and right. So it's always a good place to start. So what is this graph doing from left to right? So I'm only going to look at the x-axis for this. So the farthest I go to the left is -1. So I'm going to have x's that are greater than or equal to -1. And then it goes all the way up to 2, but notice there's a boundary line right here. So I am going to say x is less than 2. I'm just not going to say x is less than or equal to 2 because it doesn't actually land on 2. So For this one, we'd get one inequality that says x is greater than or equal to -1, but less than 2. And as far as the range goes, remember the range, we see what the graph is doing from bottom to top. So for the range, the lowest y value that we have is -1, and then from there it's going to go up forever, so we'd simply say y values that are greater than or equal to -1. For part B, again, as I look from left to right, these graphs go left and right forever, so my domain is all real numbers. But as far as the range goes, we're going to have to write two separate inequalities for this because the graph is split. So one range inequality is going to go from 0 to 4. All right, so I'm looking at this right here for the range. Notice that it does include 0, but it does not include 4. So I'm going to write an inequality as something along the lines of y values that are greater than or equal to 0, but less than 4. Then up here, now my range goes from everything that's higher than 4. So I need a separate inequality that says y is greater than 4 as another inequality. Looking over here at part C, so from left to right, again, my domain, I'm going everything from -4, and it looks like we go to the right forever, but we do not include 0. Right, I'm only looking at the x-axis here, so we don't include 0 as part of that domain. So we could say something along the lines of x's that are greater than or equal to -4, and then as a separate statement say x does not equal 0. As far as the range, looks like the lowest range value is 0 on the y-axis, and this is going to go up forever, but it's not going to include 3 within the range because that's an open circle right there. So we'd say something along the lines of y values that are greater than or equal to 0, and then I would say as a separate statement y does not equal 3. And so that's the way I would write these. You can write these with a different notation like interval notation. So let me throw those in here real quick so that we can see some of that. So for part A right there, we'll just do a separate box to show you two ways that you could write that. So your separate box on part A, again, we set for the domain because I was looking from left to right that it goes from -1 to +2. So it goes from -1 to +2. It does include -1, but does not include 2. Well, the other way to write that is with interval notation from -1 to 2. So remember, we use the hard bracket whenever you have an equal sign, and we use a parenthesis when there is no equal sign. And so this is another way that we can write domain and range, and so don't be surprised if you're checking answers and you see something like this as opposed to something like this. But they do mean the same thing, and we can write it either way.